Watching robotic tire and wheel assembly in action is a powerful example of modern automation. The process begins as tires and wheels arrive on separate conveyors, automatically sorted for the next steps. Robotic arms precisely grip each wheel, aligning it with a matching tire. High-resolution sensors verify both parts before the robots move in. Each tire is expertly seated onto its wheel by a synchronized press, applying just the right force for a perfect fit. The system checks for alignment, runout, and balance at every stage, making adjustments instantly if needed. Finished assemblies are moved to inspection stations where cameras and lasers ensure strict quality standards. The speed and consistency are remarkable. Hundreds of wheels are completed each hour, with almost no human intervention. Watching this seamless process, it's easy to appreciate how robotics and advanced sensors are redefining reliability in automotive manufacturing. Every step is designed for precision, safety, and maximum efficiency. Massive crankshafts for ships don't just happen, they're built through a complex, precision-driven process. It all starts with forging huge steel blanks, each one carefully heated and formed to withstand incredible forces at sea. These blanks are then machined on giant lathes, shaping every journal and crank web to exact specifications. Advanced CNC milling ensures perfect alignment while technicians constantly monitor dimensions and tolerances. It's incredible to see such massive metal pieces spun and cut with so much accuracy. After machining, surfaces are polished and checked for flaws using ultrasonic and magnetic particle inspections. The finished crankshaft is then balanced, assembled with connecting rods or other components if needed, and thoroughly tested for quality and performance. Watching these industrial giants take shape is genuinely impressive. The combination of human skill, tradition, and cutting-edge technology delivers parts that keep the world's largest ships moving. The process of shaping glass with advanced machinery reveals just how far precision engineering has come. The glass forming machine 5406 starts by loading borosilicate glass tubes up to 120 millimeters in diameter onto rotating chucks. Each tube is aligned with great care before production begins. Controlled burners apply focused heat to selected sections, softening the glass at the right spot. As the machine rotates the tube, mechanical arms press and form standard ground joints, ball joints, threads, or flanges, each part crafted for its exact application. Every stage is managed by sensors that monitor temperature and position, instantly correcting for even the smallest variation. Once shaped, the glass components are cooled in a controlled process to prevent stress and ensure durability. Finished items are transferred for further inspection or assembly. Observing this smooth and highly organized flow, you can see why automated glass forming stands out in the industry. Precision, speed, and consistency define every step of this operation. Micron-level precision is the heart of finished machining for crankshafts. At this workshop, skilled technicians use rare hand tools and specialized polishing techniques to achieve surfaces so smooth, imperfections can't be seen by the naked eye. Every journal and surface is measured and rechecked with ultra-sensitive gauges, pushing accuracy down to a few microns. Watching the final passes, as a flawless finish emerges, is truly impressive. This process combines traditional craftsmanship with modern measurement technology, ensuring each crankshaft meets the strictest tolerances. There's a real sense of pride in seeing such high standards upheld on every piece that leaves the shop. High-feed milling reaches a new level with the KenFeed 2X system. Using a 32mm cutter and 3 robust inserts, the machine tackles 42 CRM04 steel at 250 meters per minute with a feed rate up to 12,500 millimeters per minute. Each pass removes material efficiently thanks to thick double-sided inserts. Watching the smooth, rapid cutting and chip evacuation is impressive. This is engineered power in action. The reliability and productivity of this setup stand out in demanding milling operations. Precision engineering reaches new heights at Heisler, where massive plate roll bending machines shape the backbone of industries worldwide. The journey starts with robust steel plates, each loaded onto powerful 4-roll or 3-roll bending machines like the VRM or HDR series, ready to take on demanding tasks. Sensors and lasers check the initial alignment, providing real-time feedback to the operator's console. As the rolls engage, the plate is smoothly curved into precise cylinders or cones, sometimes for aviation wing edges or massive wind turbine towers. Throughout the rolling process, hydraulic actuators adjust the pressure with split-second accuracy. Every rotation is carefully controlled, with digital readouts guiding the pressure and alignment, ensuring each bend matches the strictest tolerances. Operators monitor the curve and thickness at multiple points, making tiny adjustments to achieve the ideal radius. In the pipe mill, rolled plates undergo tack welding to fix their shape before moving to internal and external welding stations, where advanced automated heads create perfect seams for pipelines, foundations, or offshore structures. During internal welding, a precisely controlled torch follows the seam inside the pipe, fusing the joint with a steady arc. External welding machines then reinforce the seam from the outside, building up strength and creating a seamless surface. The welds are monitored and adjusted in real time to guarantee a flawless result. The scale and sophistication of the process are stunning, blending heavy-duty machinery with high-tech automation. Perforated sheet metal manufacturing starts with feeding coils into a precision press. Sheets are straightened, then advanced beneath a die, where sharp punches create uniform rows of holes at high speed. Each punch cycle is perfectly timed, resulting in crisp patterns across the metal. The combination of clean cuts and rapid movement is captivating. This process transforms ordinary steel into versatile, high-quality perforated panels for countless uses. Retreading tires takes on a whole new dimension with the RING BUILDER 3000 system. This fully automated machine is engineered to streamline every step, starting with precise loading of each casing onto the rotating platform. Sensors verify the casing's position before the machine extrudes a layer of cushion gum, expertly filling craters and imperfections. It's impressive to see the gum applied so evenly, forming a seamless base for the next stage. Next, the ring tread ring is automatically aligned and positioned around the casing. Mechanical rollers ensure perfect adhesion as the ring is pressed down and smoothly rolled, creating a flawless bond between tread and casing. Every step is monitored for consistency and accuracy, keeping quality high while minimizing manual labor. The entire process moves at a remarkable pace. Up to 200 tires can be prepared in a single 8-hour shift, all in a compact footprint. Watching these tires take shape, it's easy to appreciate how smart automation transforms retreading into a reliable, high-efficiency operation ready for curing and final inspection. Witnessing the metal spinning of a sterling silver goblet base is both fascinating and inspiring. The gentle hum of the lathe fills the workshop, creating an atmosphere of focused craftsmanship. The process starts with a flat disc of 0925 sterling silver, precisely cut to the required diameter. The disc is secured against a spinning mandrel on the lathe, and as the machine accelerates, the silver becomes a blur under the steady hand of the artisan. Using specialized forming tools, the silversmith gradually presses the spinning metal against the mandrel. At key points, the artisan pauses to switch out the forming tool, selecting the perfect shape for each curve of the base. Each tool change is deliberate, allowing for better control of pressure and surface finish. You can almost feel the tension as the artisan guides each forming head with practiced movements. These frequent tool swaps ensure the base develops smooth transitions and precise angles. The variety of forming heads makes it possible to achieve a flawless contour that matches the intended design. Each pass is controlled, carefully shaping the silver into a flawless, rounded base. Throughout the process, the artisan checks dimensions and thickness, making minor corrections as needed to achieve perfect symmetry. Even tiny adjustments can make a big difference in the final result, highlighting the need for constant attention. Once the base has reached its final form, it's removed from the lathe and examined for surface quality. Watching this transformation, you can't help but admire the patience, technical skill, and artistry involved. Steel takes on new life at Bera Edelstahl, where advanced technology and human expertise blend to create world-class products. The process begins with scrap steel, melted in an electric arc furnace, and alloyed with elements like chromium and manganese to achieve precise chemical properties. After casting, massive ingots are hot forged on powerful presses, shaping the steel while refining its internal structure. Temperature is controlled with incredible accuracy, ensuring strength and consistency in every part. High-grade steels are then rolled into strip or billet form, meeting tight tolerances for critical applications. Automated lines and skilled technicians keep quality at the highest level. Watching tons of steel transformed into precise gears, shafts, and tools is genuinely impressive, a showcase of precision and innovation powering modern industry. The CTX 2000 Beta lathe takes heavy-duty machining to another level. With a spacious working area, it handles workpieces up to 600 mm in diameter and 2,000 mm in length, perfect for large, complex parts. The main spindle delivers an impressive 2,200 Nm of torque, letting operators tackle deep cuts and demanding materials with ease. Steady rests secure workpieces up to 350 mm in diameter, minimizing vibration for precise results. The VDI turret, equipped with driven tools reaching 4,000 revolutions per minute and 85 Nm of torque, supports a wide range of operations: turning, drilling, and even powerful milling with a 63 mm head. A solid drill, up to 80 mm in diameter, makes quick work of tough materials. The machine's advanced Y-axis, with plus or minus 75 mm of travel, enables eccentric and multi-axis machining for features that would challenge ordinary lathes. Chuck sizes up to 500 mm mean flexibility for both short and long components. Watching the CTX 2000 Beta effortlessly remove 1080 cc of material with a 15 mm cutting depth or handle 400 cc at a time during milling is genuinely impressive. Every move is carefully controlled for accuracy and finish. This is industrial technology that brings both muscle and precision together, making complex machining projects not just possible, but efficient and repeatable. The transformation of raw metals into a shining brass ingot is always striking to witness. The process starts as precise amounts of copper and zinc are loaded into a furnace at the Saint-Just-des-Vernes facility. As the temperature climbs, the metals melt and blend, creating a glowing pool of molten brass. Skilled operators monitor the mix, adding flux to remove impurities and testing the alloy's quality. You can sense the anticipation as the team waits for just the right moment to begin casting. Once the perfect composition is achieved, the liquid brass is poured into preheated molds. It's fascinating to see the molten metal flow smoothly, filling every corner. The result is a flawless bar ready for further manufacturing. Watching this blend of heat, skill, and careful control is a reminder of how classic foundry techniques still produce remarkable results today. Molten steel and roaring machines set the stage for rebar production, a true spectacle of heavy industry. Rows of solid steel billets are lined up, their sheer size and weight hinting at the power required for what's next. It all starts with steel billets, glowing hot after their time in the furnace, ready for the force of the rolling mill. Guided by automated conveyors, each billet is shaped and compressed by a series of rotating rollers, gradually forming that signature ribbed surface essential for strong concrete reinforcement. Operators keep a close eye on every pass, making micro adjustments to ensure accuracy. When the steel rods reach the right thickness and pattern, high-speed shears cut them into precise lengths in seconds. The rebars are then carried by cooling beds, slowly dropping to room temperature, while staying perfectly aligned. It's amazing to see raw steel transform so efficiently into the essential rods that support bridges, towers, and skyscrapers. Each bundle of rebar carries the weight of skill, technology, and relentless industrial power.